Pulleys are used in a variety of ways to lift loads, apply forces, and to transmit power. In nautical contexts, the assembly of wheel, axle, and supporting shell is referred to as a block. A pulley may also be called a sheave or drum and may have a groove between two flanges around its circumference. The drive element of a pulley system can be a rope, cable, belt, or chain that runs over the pulley inside the groove. Hero of Alexandria identified the pulley as one of 6 simple machines used to lift weights. Pulleys are assembled to form a block in tackle in order to provide mechanical advantage to apply large forces. Pulleys are also assembled as part of belt and chain drives in order to transmit power from one rotating shaft to another. Block and tackle. A set of pulleys assembled so that they rotate independently on the same axle form a block. 2 blocks with a rope attached to one of the blocks and threaded through the 2 sets of pulleys form a block and tackle. A block and tackle is assembled so one block is attached to fixed mounting point and the other is attached to the moving load. The ideal mechanical advantage of the block and tackle is equal to the number of parts of the rope that support the moving block. In the diagram on the right, the ideal mechanical advantage of each of the block and tackle assemblies shown is as follows: gun tackle, 2, luff tackle, 3, double tackle, 4, guide tackle, 5, threefold purchase, 6, rope and pulley systems. A rope and pulley system, that is, a block and tackle, is characterized by the use of a single continuous rope to transmit a tension force around one or more pulleys to lift or move a load. The rope may be a light line or a strong cable. This system is included in the list of simple machines identified by Renaissance scientists. If the rope and pulley system does not dissipate or store energy, then its mechanical advantage is the number of parts of the rope that act on the load. This can be shown as follows. Consider the set of pulleys that form the moving block and the parts of the rope that support this block. If there are p of these parts of the rope supporting the load W, then a force balance on the moving block shows that the tension in each of the parts of the rope must be with P. This means the input force on the rope is Te equals with P. Thus, the block and tackle reduces the input force by the factor P. A gun tackle has a single pulley in both the fixed and moving blocks with 2 rope parts supporting the load W. Separation of the pulleys in the gun tackle show the force balance that results in a rope tension of with 2. A double tackle has 2 pulleys in both the fixed and moving blocks with 4 rope parts supporting the load W. Separation of the pulleys in the double tackle show the force balance that results in a rope tension of with 4. How it works. The simplest theory of operation for a pulley system assumes that the pulleys and lines are weightless, and that there is no energy loss due to friction. It is also assumed that the lines do not stretch. In equilibrium, the forces on the moving block must sum to 0. In addition, the tension in the rope must be the same for each of its parts. This means that the 2 parts of the rope supporting the moving block must each support half the load. Fixed pulley. Diagram 1. The load F on the moving pulley is balanced by the tension in 2 parts of the rope supporting the pulley. Movable pulley. Diagram 2. A movable pulley lifting the load W is supported by 2 rope parts with tension with 2. These are different types of pulley systems. Fixed. A fixed pulley has an axle mounted in bearings attached to a supporting structure. A fixed pulley changes the direction of the force on a rope or belt that moves along its circumference. Mechanical advantage is gained by combining a fixed pulley with a movable pulley or another fixed pulley of a different diameter. Movable. A movable pulley has an axle in a movable block. A single movable pulley is supported by 2 parts of the same rope and has a mechanical advantage of 2. Compound. A combination of fixed and movable pulleys forms a block and tackle. A block and tackle can have several pulleys mounted on the fixed and moving axles, further increasing the mechanical advantage. Diagram 3. The gun tackle, rope advantage, has the rope attached to the moving pulley. The tension in the rope is with 3 yielding an advantage of 3. Diagram 3a. The luff tackle adds a fixed pulley rope to disadvantage. The tension in the rope remains with 3, yielding an advantage of 3. The mechanical advantage of the gun tackle can be increased by interchanging the fixed and moving blocks, so the rope is attached to the moving block and the rope is pulled in the direction of the lifted load. In this case, the block and tackle is said to be rove to advantage. Diagram 3 shows that now 3 rope parts support the load W, which means the tension in the rope is with 3. Thus, the mechanical advantage is 3. By adding a pulley to the fixed block of a gun tackle, the direction of the pulling force is reversed, though the mechanical advantage remains the same. Diagram 3a. This is an example of the luff tackle. Free body diagrams. The mechanical advantage of a pulley system can be analyzed using free body diagrams, which balance the tension force in the rope with the force of gravity on the load. In an ideal system, the massless and frictionless pulleys do not dissipate energy and allow for a change of direction of a rope that does not stretch or wear. In this case, a force balance on a free body that includes the load W and N supporting sections of a rope with tension T yields the ratio of the load to the input tension force is the mechanical advantage MA of the pulley system. Thus, the mechanical advantage of the system is equal to the number of sections of rope supporting the load. Belt and pulley systems. A belt and pulley system is characterized by 2 or more pulleys in common to a belt. This allows for mechanical power, torque, and speed to be transmitted across axles. If the pulleys are of differing diameters, a mechanical advantage is realized. A belt drive is analogous to that of a chain drive. However, a belt's sheave may be smooth so that the mechanical advantage is approximately given by the ratio of the pitch diameter of the sheaves only, not fixed exactly by the ratio of teeth as with gears and sprockets. In the case of a drum-style pulley, without a groove or flanges, the pulley often is slightly convex to keep the flat belt centered. It is sometimes referred to as a crowned pulley. Though once widely used on factory-lined shafts, this type of pulley is still found driving the rotating brush in upright vacuum cleaners, in belt sanders and bandsaws. Agricultural tractors built up to the early 1950s generally had a belt pulley for a flat belt. It has been replaced by other mechanisms with more flexibility and methods of use, such as power takeoff and hydraulics. Just as the diameters of gears determine a gear ratio and thus the speed increases or reductions and the mechanical advantage that they can deliver, the diameters of pulleys determine those same factors. Cone pulleys and step pulleys are a way to provide multiple drive ratios in a belt and pulley system that can be shifted as needed, just as a transmission provides this function with a gear train that can be shifted. V-belt step pulleys are the most common way that drill presses deliver a range of spindle speeds.